Good morning, all. Now, today we shall cover Ospf routing. Let me share my screen. So, Ospf routing, one word, the Great Dynamic Routing Protocol. So, what are they telling us? The Open Shortest Path First Protocol is a link state interior gateway protocol developed by IETF. IETF is Internet Engineering Task Force. Currently, version 2 is used for IPv4, that's Ospf version. And RFC, I told you RFC stands for request for comments, but when you're in practice, you're working with Huawei, at times you will refer to RFC as request for change. As a link state protocol, OSPF has the following advantages. It allows a multicast packet transmission to reduce load on the switches that are not running OSPF. Classless interdomain routing, that where we shall have, instead of having like /4/24/8/16, you can also have /25/26. That's classless. So load balancing among equal host routes, packet authentication. Yeah, now OSPF is widely accepted and used as an IGP. I told that IGP is an interior gateway, but the others, RIP, routing, there's RIP. We also have RIP as one of the interior gateway protocol, but OSPF is most preferred. You understand the basic OSPF configurations and principles by configuring a single area OSPF. Now, what about single area OSPF? Other areas you can find them in at the professional level, where you can configure other areas. But for HCIA, we normally focus on a single area OSPF. So upon completion of this task, you'll be able to learn the basic commands of OSPF, learn how to check the OSPF running status, learn how to control OSPF routing selection using costs, understand the advertisement of default routes in OSPF, learn how to configure OSPF authentication. Okay, now let me open up my NSP here. Excuse me, sorry. Okay, now this was just labeling. Now let's go. So I was saying I would be faster because we had done this basic configuration in our previous lab. So I'll be fast here. So let's go into our router one. Some of the things I'm doing, I've already explained about them in the previous lab. Yes, so now once the display IP interface brief, just to confirm if what you just configured has taken effect, you see that even here, you see that the same applies here. You see that. So now in the previous labs, we made use of static route, but in this case, we're going to use the Ospf routing. How would you start? So the first thing is start with a process, Ospf process. You have to specify, you have to create a process. So by default, we use one. Even if you don't put it like that and just say Ospf, they will bring it for you that one. Now we are using area 0, which is the backbone, and you're advertising which networks. Now you've gone into the area 0. Now here you have to advertise a network. Now which networks are you advertising? Now I'll do this to see the networks I'm advertising. So my first network will be network. So to see which possible commands you can have in that position, you can use a question mark. You see, network number. So here it will be 10.0.1. I'm on router 1, right? Dot 0. Now here we use the wildcast mask. Now let me do something small. How do you get a wildcast mask? So we have 255, which is /32. 2550. Now, how do we express /30 in an octet form? We shall have 255 255, 255. We went through this in the previous classes. If you don't know how to do this, 252. Now, if you do the subtraction here, you will end up with 0, 0, 0, 3, like that. So this is what we call a wildcard mask, the reverse mask of /30. Okay. So here I have .0.0.3. Which other network? 10.0.2.0, the mask, the wildcard mask, .3. Which other one? The loopback network? 1.1.1.1, 0.0.0.0, like that. Because if you subtract /32, you will get that. Yes. Now I'm done with the router 1. So let's go to router 2. So as I told you, you can do save all here. Just in case the device goes off, your configurations will remain. Until we see the message. Okay, let's go to router 2. Ospf. I told you by default, they'll bring that one area, still 0. Network, still there's 10.0.1.0 flash, and then what hits that one. Other network is 10.0.3.0. Yes, .3. Yes. Then the loopback network 2.2.2.2, 0.0.0.0, like that. It's gonna route 3. Okay. What next? Checking the Ospf peer status. Okay, let's go to the guide. So they're telling us display routing table. Now, initially, when you set display routing table before configuring Ospf, this is how it appears. Now let's check how does it appear after configuring Ospf. Can you be able to see the Ospf routes in there? Let's say display IP routing table. Now you see, you're able to see the Ospf protocol. Ospf preference is 10, the cost is 2, like that. Now if you want to be specific, you have to go and say protocol Ospf. That only bring for you the Ospf routes. Okay. OSP, we have done that. Display Ospf status. How do you display Ospf status? Let's go through this. Now I'll come here and say display Ospf. Excuse me, I'm being called. Just a few minutes. So, sorry. When I'm not class, that's why it's very up with a brief. So I'm going up to my class, not class around okay. Then I'll go there. All right. Sorry about that. So I'm saying this Ospf here. Now let's do some studying here. Now Ospf process 1 is router ID 10.0.1.1. Now the router ID. In fact, my configuration I wasn't specifying the router ID. It's a device that you manually configure the router ID. But by default, they have chosen 10.0.1.1, which is this interface here. The codes are becoming. Yes. Yeah. Take the everybody was with the Chantal. No, let me could have been a class and then send it at 10. I'm very sure that let me call you back. Guys, I'm very sorry. Anyway, let's go through this chap. As I was saying, first router ID 10.0.1.1. So the advice to manually configure the router ID, but by default, they will choose the IP address of the interface. And there is a criteria we use. So please read the notes to know when we choose the IP address of the interface, the router ID, when we choose the loopback interface, all that. As the router ID. So area 00 interface is .1.1. Now it is 00Z neighbors that they're talking about information about the gigabit, this interface here. Now the router ID is 10.0.0.2.1 of the other neighbor, this neighbor here. And the address is still the same. State is full. Mode, neighbor is a master, priority 1. DR is 10.0.0.1.1.1. Border DR is 10.0.2.2.1.2. But please go through the notes to understand when we have the DR, how you select the DR, all that is fully explained in that PDF, the training material. Then we have states like full, when we have a status full, when you have a status two-way. So you have to go through a lot of other states. Down, innate, load balancing, load exchange, flow exchange. You get not flow exchange, but it's just full load balancing. When you have extart, you get like what is first, what comes first. But the stable states, we have two and full. But when we have the two-way, when you have the full, you should understand that from the notes. Okay, yeah, that's it basically. Other routers, it's the same. We said this Ospf. Yeah. Yeah, just like that. Let me see what else to do here. No, this will be food for thought. Yeah, like you write this out. Now we have also authentication. You can go on interface and enable authentication. We have area authentication and interface authentication. Which one takes precedence? You should understand that. Otherwise, I put there. That's all about Ospf.